Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Chapter some basic principles and techniques in organic chemistry, and we are doing the topic empirical formula and molecular formula. Hello friends, in the last lecture we have studied about how can we have detect the quantitative analysis of the elements that are been present in the organic compound, whether that be carbon, hydrogen, oxygen, sulfur or phosphorus. And now based on that only we are going to determine that what is actually empirical formula and what is actually molecular formula and what is the relation between these two. So let us talk about that. So talking about the empirical formula and molecular formula, let me tell you that every organic compound is made up of the elements, and that also in a proper proportion. And so that is the reason that we have to determine that what is the percentage of a particular element that is present in the organic compound. And that is what we have discussed about the quantitative analysis earlier only. And based on that, all those things, we are going to start with the empirical formula and molecular formula. So starting with the empirical formula, it is the thing that we have did in the chapter, that is some basic concepts of chemistry also. So let us understand it again. That is what is empirical formula? That is, empirical formula of an organic compound is the formula that shows the smallest ratio, and that all ratio should be in whole number, and that the smallest ratio of the number of atoms of each element present in the molecule of the compound. So empirical formula gives us the detail that how much in smallest ratio that which elements are being present in that organic compound. So that gives us a idea, and also it gives us a ratio that is in a smallest ratio form that the organic compound can be represented with. So this is the empirical formula that we have discussed about, and we are going to do a deep analysis that, so in the terms of an example also, that we are going to take so as to understand it. And talking about the another one, that is molecular formula. So what is actually molecular formula? Molecular formula of an organic compound gives the actual number of atoms of each element present in a molecule of a compound. So let me give you a short example, and this is the one of the most simplest one that I could make you understand. That is when it comes to benzene. Again, I am taking the example like this one. So benzene consists of 6 carbon atoms and 6 hydrogen atoms. So making this to be because it is giving us precise value or exact value of the atoms that are being present in the benzene. And talking about which kind of atoms that are being present, that is carbon and hydrogen. But carbon is present, 6 atoms of carbon are being present and 6 atoms of hydrogen is being present. So therefore this is what we have got is basically known as the molecular formula, because this gives us the exact detail of the number of atoms that are being present in the organic compound, and in this case it is benzene. So this is what we could write it as molecular formula. So talking about the another one, that is the empirical formula. So this is the ratio that we have got over here. So suppose the two kind of elements that are being present in benzene, that is carbon and hydrogen, and if we compare, so the total number of the carbon that we have got, it was 6:6, that is 6 atoms of carbon and 6 atoms of hydrogen. But this can be reduced into a smaller ratio. So I could write it in this way also, that is 3:3. But again, this could be written in a smallest ratio, or I could write it as 1:1. So now this is the smallest ratio of what I have got as the carbon can be present and hydrogen are being present in 1:1 ratio. So because this is the most simplest and one of the most smallest ratio that we have got over here, and the both are of whole numbers. So therefore I could write that C one carbon atom, and this is again one hydrogen atom. So therefore this is what I have wrote based on the ratio, the smallest ratio, and in this case I have got to know that the carbon is only 1 time and that of the hydrogen is also 1 times, because they are both of the ratio 1:1. So therefore this is what it is known as empirical formula. So there is a difference between the molecular formula and empirical formula. But yes, it is not necessary that every time the molecular formula and the empirical formula would be different. Sometimes they can be same also. So let me give a short example so as you could understand. And but we should never consider that the molecular mass or molecular formula is equal to that of the empirical formula, unless we know the deep detail that how much quantity or the quantitative analysis that we have did. So for example, if I take the example like methane. So methane is the one which consists of 1 carbon atom, and that is of 4 hydrogen atoms. So this gives us the exact detail of the how much amount of the carbon and how much that is atom of the hydrogen is been present. So therefore I could easily convince that this is basically the molecular formula. But talking about that is the empirical formula. So because I know that there's two types of atoms that have been present in the methane, that is carbon and hydrogen. I'm just making out in a ratio form. So I could see that the carbon is present 1 times and that of the hydrogen is present 4 times. So can I reduce this to a simple ratio? So as means the 1 can be converted into less than 1 and 4 can be less than 4. No, I can't do that. That's the reason that it is the most simplest ratio of the methane that it could be represented with. So that is the reason it could be represented as carbon is only 1 time, or the atom is only 1 time, while that of the hydrogen is of 4 times. So again, this is what we have got the same like the molecular formula, but what we have made an intention, to find out what is the empirical formula. So therefore this is also can be called as the empirical formula. So somewhere it can match or somewhere it don't. So that is the reason we always rely with the molecular formula, and from that only, or we always rely with one of them, and so as to predict that what would be actually its molecular formula and the empirical formula. So related to this, because they are related to each other, somewhere they would be same, somewhere they would be different. So that is the reason I am going to explain that how can we relate the empirical formula and the molecular formula. But talking about the more further thing, this detail is what we have did in our previous chapter also, that is in some basic concepts of chemistry, and then also we have got to know that is how can we calculate the molecular formula, how can we calculate the empirical formula, and what is the relation between them. So let me give a short idea that what we should do so as to calculate the empirical formula of a particular compound. So there are basically the 3 steps that we have to involve. The first thing that we have to do is we on the basis of the quantitative analysis that we have discussed earlier in our earlier lectures, and from that will get to know that what is the percentage of carbon, hydrogen, and so on. And suppose in that case we have didn't got the what is the percentage of the oxygen atom, then we could easily calculate that. This is very easy. That is, we have to follow few steps, and among that the step number 1 is analysis of the percentage of the atoms that are been or the elements that are been present in the organic compound. So suppose everything that is carbon, hydrogen, sulfur, phosphorus, if that, or halogen also, if that could be determined, and in that case suppose the oxygen is the one which we have did a lecture, that is how to determine the percentage of the oxygen. But somehow suppose if we are not able to calculate that one, and we have calculated the rest of the elements that are been present in the organic compound, then how to calculate? So therefore the percentage of the oxygen can be calculated as 100 minus the percentage of each element that is been present in the organic compound. So by this we could easily determine that what is the percentage of the oxygen, because since it is an organic compound, obviously we have calculated the carbon, the percentage of carbon, hydrogen, and all. So that is the how we could estimate the percentage of oxygen. So there's a numerical also that we are going to discuss, and that we will be discussing. And talking about the next one, that is step number 2. So in step number 2, what do we do is we arrange the percentage of the atoms of the respective atoms, and from that we do is we divide it with the atomic mass. So suppose if we have got a percentage of carbon as 20, so and hydrogen as suppose like 40, and oxygen is the rest of the thing. So how to determine the atomic ratio? It is very simple. The percentage that we have got is of carbon, and that would be divided by its atomic mass. And that of the oxygen can be determined by the weight that we have got, and that is 40. Suppose 40%, that is 40 gram, divided by the atomic mass of the oxygen. So this is how we will, and that of oxygen also we could determine that, and that is how we could determine that what is the atomic ratio of the hydrogen, oxygen, and so on. And this is how we could calculate the atomic ratio of that. And this is the second step that we have did. And talking about the third step, the third step is, suppose we have detected that what is the atomic ratio, that is for carbon we have divided by, suppose 20 divided by 12, because that is the atomic mass of the carbon. And for hydrogen it is 1 divided by that is sorry 40 divided by 1, because the percentage of hydrogen it was supposed found to be 40, and divided by the atomic mass of hydrogen it is 1, and that of the rest of the thing it would be of oxygen divided by 16. So this is the atomic ratio that we have got, but the atomic ratio can be of variable different numbers, and it is not necessary that they would be a whole number. They could be basically a decimal number also. So what we have to do is we have to search a smallest number among the three elements that we have discussed about, like carbon, hydrogen, oxygen. And in that, the smallest atomic ratio that we have got, and that is the number that we have to divide with every atomic ratio, and from that we would get a particular ratio of the carbon, hydrogen and oxygen, and that is what we have got. That is the most simplest ratio, because we have divided by smallest number, and that makes us to determine what would be the empirical formula. And that is the empirical formula that we would calculate, and that is the thing that we are going to discuss in the numerical also. But this is the thing that I'm trying to revise from the chapter some basic principle, some basic concepts of chemistry. And so from that we have got to determine that what is the empirical formula. And from the empirical formula we could be easily determining that what would be basically the empirical formula mass. So what will be the empirical formula mass? It is nothing but the sum up of all the atoms, atomic mass of the elements that are being present in the empirical formula, and that is how we discuss the empirical formula mass. And talking about the molecular formula mass, again it will be very similar to that of the empirical formula mass. What we have to do is we have to sum up all the atoms of the element that are being present in the molecular formula, that is atomic mass, and then we will get to know that what is the molecular formula mass of that particular compound. So in this case we have to relate the empirical formula with that of the molecular formula. So the relation is very much simple, and the relation is that is molecular formula is equals to n into empirical formula. And what is actually n? This n is nothing but the ratio of the molecular formula mass to the empirical formula mass. So this is also we have discussed in this lecture and in the previous chapter also. That is some basic concepts of chemistry. So I could write this as molecular formula mass, or we could write it as molecular mass divided by empirical formula mass. So once we got to know the empirical formula, and later by searching or by making analysis that what would be basically the value of n, we could be easily determining the molecular formula, and vice versa we could determine what would be the empirical formula and all. So this was it that I wanted to explain the relation between, as well as the definition of the empirical formula and molecular formula. So that's it. So thank you friends for watching this video. I hope you have liked this video and you have understood this video very clearly, and you will share this video with your friends, and don't forget to subscribe to Ekeeda channel. Thank you so much.